Attention. Topic is high availability, gateway high availability. Is my screen visible? Is the screen visible?
Yes, yes, yes.
Gateway high availability means high availability for gateway. And guys, you can also say FHRP, first hop redundancy protocol. Why we need it? Anyone? Why we need redundancy for the default gateway?
Default.
Okay, in this scenario you can see I have two VLANs. For VLAN 10 we have subnet 192.168.10.0/24. For VLAN 20 192.168.20.0/24. This is the incorrect, let me correct it over here. And guys, either I can configure gateway IP address on distribution layer switch 1 and distribution layer switch 2, or I can configure on router, right? In both scenario you can configure FHRP protocol. On layer 3 switches also you can configure it, or you can configure it on router. On any layer 3 devices you can configure FHRP protocol. Fine. So for both VLAN we need gateway. Okay. So guys, let's suppose router 1 is my gateway, right, for both VLAN, or router 1 is the gateway for VLAN 10 and router 2 is the gateway for VLAN 20. We can configure like that also. Then whatever IP address we are going to configure on router 1 will be the gateway for all end devices in VLAN 10, correct? And whenever router 1 will goes down, I have to manually change the default gateway IP address on all end devices. So that's why we come up with protocol, FHRP protocol. What FHRP protocol will do, see where we will enable it first. So we are going to enable it on the gateway. So this interface is the gateway. Router 1, let's say this F0/0, and this one is also F0/0. By the way, here I have 4 interfaces. So I have 4 physical gateway. I have total 4 physical gateway, right? And we can configure one gateway IP address to end devices, correct? And if that gateway will goes down, then I have to manually change the IP address. So to avoid it, we are going to configure FHRP protocol on all the gateway interface, right? Let's say this is 0/1 and this one is also 0/1. Done. So on this all gateway, what we are going to do, we are going to enable FHRP protocol, and there are 3 types of protocol under FHRP. What this protocol will do, guys, all protocol is going to create one logical IP address. With the help of 4 physical IP addresses, it will create one logical IP address. Let's consider this subnet, VLAN 10 subnet 192.168.10.0/24. For this subnet, guys, these are the physical gateway, and the protocol is going to create one virtual gateway which is 192.168.10. Let's say 100. This is the virtual gateway IP address. We are going to use this virtual gateway IP address for end devices. We'll assign this IP address as a gateway on all end devices, and the protocol is going to decide which interface, which gateway will be the active gateway. One gateway will be the active and rest all will be in standby state, right? Again, there are multiple states, guys. We will discuss about the state, but all will be backup for active. If active will goes down, then the standby will become active. Got it? So that's why we come up with FHRP protocol, and under FHRP protocol we have HSRP, we have HSRP, then we have VRRP, and then we have GLBP. So we are going to learn these three protocol one by one. We'll start from the HSRP. So first of all, what is HSRP? HSRP stands for what, guys? HSRP stands for Hot Standby Router Protocol. VRRP stands for Virtual Router Redundancy Protocol, and GLBP stands for Gateway Load Balancing Protocol. HSRP and GLBP both are Cisco proprietary. HSRP does not provide load balancing, right? We can achieve load balancing in HSRP with the help of multiple groups. Within the group we cannot achieve the load balancing. That's why Cisco have designed what? GLBP. In GLBP you can achieve load balancing within the group. So first of all, I am going to write down here the basic points about the HSRP, and after that we will discuss all the points one by one. Okay. So guys, at which layer this protocol works? This is a very important. Anyone have idea which layer protocol this HSRP is?
Layer 3.
No. It is an application
7.
layer protocol. Yes, layer 7. And if it is layer 7 protocol, then definitely it will be using either TCP or UDP at transport layer, right? And guys, it is a layer 7 protocol, means HSRP is going to generate their message at which layer? At layer 7, at application layer, right? Then at transport layer it uses UDP. Before that it is an Cisco proprietary protocol. We can only run this protocol on Cisco devices. Then the hello time means in the HSRP we have one message, that is hello message. All routers, once you will enable the HSRP, all routers will send this message, hello message, and the timer of hello message is 3 seconds. Means after every 3 seconds router will be sending this message, hello message. And guys, hold on time is 10 seconds. Hold down time 10 seconds, means the neighbor gateway is going to store that information for 10 seconds, right? It uses UDP at transport layer. If it is using UDP, then you have to learn the port number as well, like which port number is assigned for HSRP protocol. So guys, the port number of HSRP is 1985. This port number is assigned for the HSRP protocol, right? Then it is a dynamic routing, dynamic protocol. So it will send their message like hello message on multicast address, right? So one multicast address is also reserved for this protocol, multicast address, and that multicast address is 224.0.0.2. 224 means the multicast group. All class D IP address start from this range, right? And 0.0.2 is reserved for HSRP. Like guys, for the routing protocol, for EIGRP, OSPF, we have what? Multicast address. Then the next thing is priority. See, soon you are going to understand the election, how one router will become the active router, and for the election it is going to use priority. So, and by default priority is 100 on all devices. So priority will tie, because on all devices priority is same, so it will use IP address, the highest IP address of the interface. Then about the HSRP we can say track is inbuilt. Track is inbuilt means, see, suppose this interface is the active gateway, right? So guys, if this interface will goes down, or line protocol of this interface will goes down, definitely this interface will become the active. What if this link will goes down, this link, if this link will goes down, what will happen in that scenario? In that scenario your router 1 will be a still active router and will be for dropping the traffic. So that's why we have a track feature, right? So the protocol can track the ISP. It can track the ISP. If ISP is down, then it will down the gateway. Then the secondary interface will become, secondary gateway will become the active. And track feature is by default inbuilt in the HSRP. So you don't need to use external track feature. Sometimes you will see, like in the NAT also, whenever we will discuss the failover, this is also what failover. This is what failover only. So whenever we will talk about the failover, I will be using the track term, right? Means track the ISP. If ISP1 is down, shift the traffic, right? So guys, for the external track we are using IP SLA. We will learn IP SLA later. For now, just keep in mind that track feature in HSRP is inbuilt, right? These are the basic information about HSRP protocol. Then you can say by default decrement, decrement in priority is 10. Right, means whenever active router will goes down, it will decrement priority by 10. It will decrement priority by 10. So let's say by default priority on all the routers is 100, and guys, if F0/0 will goes down, it will decrement their priority by 10. So priority will become what, 90 over here. And now you can see router 1 have lower priority. Definitely this interface have priority 100. So now this interface will become the active interface, right? So whenever the gateway will goes down, their line protocol will goes down, it will decrement in priority by 10. After that guys, the most important thing is, see here I have one PC whose MAC address is, let's say, A. MAC address is A, and the IP address is anything, let's say 10.1.1, sorry 192.168.10.1. Done. Now the gateway IP address. Gateway IP address is going to be the virtual IP address. Let's say 192.168.10.100. Fine. Now let's say this PC A need to access internet, or this PC is going to forward traffic to 8.8.8. So source IP will be 192.168.10.1, destination IP will be 8.8.8.8. Source MAC will be A and destination MAC. For the destination MAC, this PC is going to look up their ARP table, ARP. If entry is not there in ARP table, then it will generate the ARP request message. Now it will generate ARP request message for which IP address? For this IP address, for the virtual gateway IP address, right? and guys, all the gateway is going to receive this ARP request message. So only active router will generate the reply, right? So if let's say this router is generating this interface is generating the reply, then my PC will forward traffic to this interface. If this interface is generating the reply of ARP request, then my PC will forward traffic to this interface. If router 2 is generating the reply, this interface, then PC will forward traffic to this gateway. And if this gateway is generating a reply, then PC will forward traffic to this gateway. So everything depends on the MAC address, destination MAC address of default gateway in the ARP table, right? Because how switches are going to forward the traffic. Let's say this interface MAC address is B, this interface MAC address is C, D and E. So guys, if destination MAC is B, then switch is going to forward traffic to distribution layer switch 1, because it will learn B MAC address on this port. Then distribution layer switch 1 is going to forward traffic from this port, because it will learn B MAC address on this port. If the destination MAC address is C, then again switch is going to check their MAC address table. It will check C MAC address is available on which port. From that port it will forward the frame. So where traffic will goes, to which default gateway traffic will reach, depends on destination MAC address in the packet, in the actual message. Okay. So and HSRP uses one virtual MAC address, that is virtual MAC address of HSRP you can say is virtual MAC address is 4 times 0 4 times 0, then 0607.ec, and 2 value is still pending, so it is XX is nothing but your group number, right? So let's say the group number, HSRP group number is 10, then the MAC address of default gateway is going to be AC 10, like this, right? It will represent in hexadecimal. And guys, if group number is 255, then what will be the MAC address? Hexadecimal representation of 255. Hello, am I audible?
Yes, sir.
Yeah. So if the
So
group
we
number
have
is
to
255.
so we have to convert 255 to in hexadecimal,
Yes.
correct?
Correct.
F.
If the group number is 250, so guys, the hexadecimal value of 250 will be what? FA. So your destination MAC address will be FA, like this. Okay. So the last 2 value is nothing but my group number.
So, sir, in HSRP, that's the default gateway, MAC address of default gateway, this one? That's what you mean, right?
Yes, default gateway of MAC address. Correct.
Thank you.
And guys, you can create up to 255 group on one router or on one layer 3 device, we can say. So maximum group in HSRP is 256, because it is 8 bits value, so range can be 0 to 255. After that, we can configure the authentication as well here. So HSRP support 2 types of authentication. One is plain text authentication, plain text authentication, and the second one is MD5 authentication, encrypted authentication. And one more thing, that is preemption. Don't worry, we'll understand the preemption. Preemption is disabled by default. These are the points, basic points about HSRP protocol. Anyone have doubt in this? All clear? HSRP states. So guys, the first state is disable, the second one is init, initial, and the third one is speaking, fourth one is listening, fifth one is learning, sorry, after speaking, listening, and then standby, and after that active. So active router means the state of HSRP is active. If I am saying active router, so active router is nothing but the router whose state is active. And always keep in mind, for one group only one router can be in active state and one router can be in standby state, and rest all routers will be in listen state, listening state. This one.
There is also a learning state also.
Which one?
Learning, I think so.
Okay, we'll see that. Wait. So guys, for one group one router can be active, one router will be a standby, means a standby is nothing but the backup of active router. And if you have more than two gateway, like 3 gateway are there, then all the remaining routers will be in listening state only. All the remaining router will be in listening state. And before listening there is one more state, that is learning, as he said. Learning, speaking, learning, and listening. So the first state is init. See, first try to understand the states only, then we'll see the HSRP. These things like the preemption here and the track, and after that while configuring I will explain everything. I will show you even all message. So init is, see, before init disable. Disable means guys port is down, the gateway interface is down. When the gateway will come up, the first state will be init state. Init means initialization. This is the, you can say, a starting point, right? Whenever router will powered on, or let's say you have just enabled the HSRP on the interface, so the first step is going to be initial state, init state. Okay, so sometime interviewer can ask you like about the init state, so you can say just after enabling the HSRP or while booting, right? Let's say router is booting and HSRP is already enabled on their interface, so in that scenario also state is going to be init. And let me do one thing here, this is not in the sequence, let me correct it. Let me write these all in sequence. One second. Yeah, so first one is init, you can say, because disable is initial state. Disable means put is down. So when we will enable the HSRP, first state is going to be init. After that, learning state. Learning state means what? This learning means router is waiting for HSRP hello message. It is waiting for HSRP hello message. You have enabled the HSRP on the interface of router, right? First state is init, initial state. After that, it is going to listen for the HSRP message, that is HSRP hello message, from the active router or from the standby router. If there is any active router, let's say here I am going to add one new router, right? So that new router will first listen. That new router will first learn about the active router, that active router is already there in the network or not. If it will not receive any hello message with the lower priority or higher IP address, then it will declare their self as active, right? Their state is going to be moved. Right? So learn means just trying to know the active router and standby router, and how a router will came to know about the active router and standby router with the help of HSRP message, that is hello message. So you can say logically it is waiting for hello message, HSRP hello message. After that, guys, listening state. What is listening state? You know, in the initial state and in the learn state, router don't know about the virtual IP address. My virtual IP address is 192.168.10.100, let's say. In the listening state, router is going to listen the virtual IP address. Right? Router knows the virtual IP address of the group. First, we are going to define the group, and then we are going to define the IP address, the virtual IP address. Right? So in that particular group, it will knows the virtual IP address. Right? And again, still it is listening for the active and standby router, if active and standby router is already there in the network. So it is, you can say, still waiting for hello message from the active and standby router. After that, guys, we have a speak state. Speak. Sometime you will see state is speak. Even after some time we are going to configure the HSRP, so you will see these all state. Speak state. In the speak state,
Sure.
router is going to, yeah.
Sorry to interrupt you. So what's the main difference between the learning state and listening?
The virtual IP address. In the listening state, it is going to know the virtual IP address.
Thank you.
And in a speaking state, router will start sending hello message. Router will start sending hello message. So let's say on the router interface, I have just enabled the HSRP protocol on this interface. First state is init, then learning state. Means it is waiting for the hello message from the active router, or you can say the standby router. And this router don't know about the virtual IP address. In the listen state, it is going to knows the virtual IP address. That virtual IP address is 192.168.10.100, and is still waiting for the hello message from active router and standby router. And guys, then state will move to speak state. In speak state it will send their on hello message. We'll see what information it will send in the hello message, don't worry. But when router will initiate sending hello message? In the speak state, right? After that, guys, next state is standby state. Standby state. So what do you mean by standby state? Standby is nothing but the backup of active router. See, in the speak state, router have sent their hello message and it have received hello message from the other routers as well. That means now router have knowledge about the priority, about the IP address, the physical IP address of all gateway. Now router can decide which router is the active router, which router is the standby router. Correct, guys? So a standby router is backup of active router. The router who will have second highest IP address or second lowest priority will be in a standby state, and rest all routers will be in which state?
Learning.
Learning or listening? Listening. In the learning, router even don't know the virtual IP address in the listening state. Right?
Thank
And
you.
guys, if router have the lowest priority or the highest IP address, then that router will become the active router. So active router is the router who is responsible to forward the traffic. Router who is responsible to forward the traffic. A standby router means the router who is ready to take handover of active router, who is ready to become active. If active bill goes down, quickly a standby router will become what? Active. And rest all routers are just listening. Right? These routers are just checking. It means keep the eye, on. Keep checking everything. Because let's say active router has goes down, then what will happen? A standby router will become active. Now one router should become what? A standby quickly for the backup of new active router. So there are multiple router in the listening state, and these all routers are checking. So again, from the listening state, one router will move in standby state. All clear? Now, guys, in this scenario, router 1 on router number 1 IP address is 192.168. Or leave this scenario. Let me take you here. Are you able to see this topology? Is topology visible to all?
Yes, sir. Yes, sir.
So
Yes.
by default priority on all devices is same, that is 100. Then guys, which router is going to become active router? The router who have highest IP address. That means router 3 is going to become what? Active router. But you can see the link. Here I have 8 Mbps bandwidth, here I have 4 Mbps bandwidth, and here I have 2 Mbps bandwidth. Router 1 should be your active router if this link is up, or if router 1 is up. Right? But if you will configure HSRP on all routers at the same time, then only router 3 is going to become active. Let's say I have configured HSRP on router number 1 and router 1 have become the active router. After that I am enabling HSRP on router number 2. Then guys, your router 1 will be the active router only. Until and unless router 1 will not goes down, the election for the active router will not happen. Then meter it have lower IP address or higher priority. If active router is present in the topology, then there will be no election for active router. So that's why we have concept of preemption. So if you will enable the preemption, then what will happen? It will preempt, right? If preemption is enabled, then election will happen every time. Whenever a new device will come up in the network, a new gateway will come up, it will perform the election for active router. All points, anyone have question, anything? Election for active router. So first thing is priority. Highest priority, and if the priority is same, then highest IP address, right? So in my scenario, by default priority on all the devices is same 100. So guys, election for active router will happen on the basis of what? On the basis of IP address, and router 3 have highest IP address. I am talking about the physical IP address, physical, not the virtual IP address. Done. So first of all, let me access this PC1, and guys, on PC1 I'm going to configure one IP 192.168. Let's say 10.10/24, and the gateway IP address is the virtual IP address 10.10.100. If I will configure .1 then PC will forward traffic to router number 1. If I will configure .2, then PC will forward traffic to router 2. If I will configure .3, then PC will forward traffic to router 3. In this scenario, whenever your gateway will goes down, then you have to change the gateway IP address manually. So that's why we are going to configure here virtual IP address. Done. Now can I ping this virtual IP address? Ping 192.168.10.100. Ping is working. That means HSRP is already configured over here. So what I am going to do, I am going to remove the HSRP configuration first, and so IP interface brief exclude unassign. Yeah, IP is also there, so IP route include 0.0.0. Yeah, default route is also there. That means I can ping 8.8.8 internet, and source fast ethernet 0/0. From the LAN interface, am I able to ping the gateway? No. On the ISP router, so IP interface brief. So 1.1.1 is there. These are the IP addresses on the physical interface. Guys, don't worry about the configuration in this section, right? On the ISP router configuration or the configuration between edge router and internet router, don't worry about the configuration of these WAN link. These are the WAN link, right? We are talking about this LAN links only, right? These are LAN link. So let me fix it. Why ping is not working? So IP NAT. Okay, I can do one thing. So run section NAT. Not running. This is the reason. So IP route. There is one static route. Very quickly let me enable NAT here, interface S2/0, and again don't worry about the NAT configuration. This is the outside interface, and interface F0/0 IP NAT inside. Exit. Then I am saying access control list number 10 and permit 192.168.10.0.0.255 and IP NAT inside source list number 10 and interface serial 2/0 overload. Let me enable PAT here and do so history. I'm going to copy this command and will paste on rest all routers. And from this router now you can try to ping 8.8.8, ping 8.8.8 and source F0/0. From the LAN interface, see I am able to ping internet. Now ping is working. Means my end devices can now ping internet. See the state of this router is. Guys, HSRP is enabled over here. This command I am going to remove it. Interface F0/0, say no. Done. This is default configuration. Done. I have removed the HSRP configuration. Yes. Now can PC ping, guys? If I will ping from PC1 to this gateway, see now ping is not working. The reason why PC1 is not able to ping?
HSR is
Virtual
not.
This
IP
virtual
not
IP address is
configured.
not available. Yes, ARP hyphen ARP. There is MAC address, right? This MAC address will expire after 41 second, and after that, if this PC will try to resolve the MAC address, it can't. It cannot resolve, right? It can't. The reason, this virtual IP address is not available. So now we need to configure the HSRP. And to configure the HSRP, before that I have saved the configuration. Let me save this router configuration also and this router configuration also, because this configuration is going to be same for other protocols as well, like for VRRP and GLBP. On router number 1, on PC number 1, I can do one more thing. Yes, on R1, to enable HSRP, we need to run this command 0/0 standby and then group number. And range of group number is, guys, 0 to 255. See, there are two versions of HSRP. There are two versions of HSRP, version 1 and version 2. Right now I am talking about version 1. The difference between version 1 and version 2 is, the first difference is in terms of virtual MAC address. Virtual MAC address is different for version 2. And guys, we come up with version 2 for very large network, because see, in version 1 we can create only 255 group, up to 255 group. So in version 2 you can create more than 255 groups. You can create around 4000 group, around 4000 groups in version 2, 4095. Second difference. And third difference is in terms of multicast address. For version 2 we have 244.0.0.2 MAC address, right? For version 2 we have 224.0.0.102 MAC address. Let me write here this one also, because it is also important. Version 1 and version 2. So first difference is in terms of MAC address. Virtual MAC address 410, then 0c70.acxx. This is nothing but the group number. On PC number 1, guys, see the MAC address. Is MAC address same? Yes. And in last value is 01. This is nothing but the group number. Group number was 1 on the router. Now see the MAC address. There is nothing. So if you will ping now, ping this IP address, you are not getting this error. Earlier you were getting this error, request time out. This time you are getting destination unreachable. Destination is not reachable, because earlier MAC address was there. This was the previous older entry, right? So this is the MAC address for version 1. And if I will talk about the MAC address in version 2, so MAC address is in version 2 F, this one. Again, X is nothing but the group number in version 1 and in version 2, in both version. Then guys, as I told you, group, maximum group you can create in version 1 is 02255, but in version 2 we can create group 024095, 12 bits value, right? The third difference is in terms of multicast address. So what is the multicast address for version 1? 224.0.0.2, and for version 2 MAC address is .102. Yes, both are UDP based protocol. So UDP port number of version 1 is 1985, and UDP port number for version 2 is 2029, I think. You can verify it, okay? I think 2029. These are the difference. That's it. Otherwise the configuration, rest all, these all points are exactly same except these 4 things. Fine. So in version 1 here you can see I can create up to 255 group. So let me say group number 10, and then guys it is asking for the IP address. What virtual IP address you want to configure, and make sure this virtual IP address is going to be same for all the gateway. On all the gateway you have to configure same virtual IP address. So virtual IP address is 192.168.10.100 because I have already configured it this IP address as a gateway on PC1. So hit enter. Now again from PC1 try to ping this IP address. Now why ping is not working? Ping should work now, and ping will work. Just wait for some time. 192.168.10.100 and here I have configured same IP 192.168.10.100. Correct. So this the reason was because of guys HSRP state. Now you can see this router is in active state, right? State moves from standby to active. This is a log message. The complete log message is, we will have one session guys for the log message, like how to read the log message, right? Like you can see there are multiple symbol, percentage symbol is there, star is there, time is there, date is there, right? This value. So we will have one session to read the log message, but this log message is for HSRP protocol saying fast Ethernet 0/0, which is the part of HSRP group number 10 and state stand by to active. So now from PC1 if you will try to ping, see ping is working because PC can resolve the MAC address of default gateway now. ARP, see the MAC address. The MAC address is exactly same, right? And this is what the group number. Guys, hexadecimal value of 10 is 0A. Done. So I have enabled HSRP on router number 1. I need to enable it on router number 2 also. And to verify it, simply I can run command show standby, right? So you can see fast Ethernet 0/0 group number 10. Standby is enabled on this interface F0/0 and group number is 10. The state is active. State is active. Two state change, last state change at this time, and the virtual IP address is 192.168.10.100 and the virtual MAC address is, see the virtual MAC address exactly same, right? And now guys, this is the virtual MAC address of active router and this is the virtual MAC address of local router, right? Local virtual MAC address. After that hello time, as I told you, 3 seconds, hold on time 10 seconds. This router is going to send next hello message after 2 seconds. Preemption is by default disable. Active router is local router, means this router is the active router. Who is the standby? Standby is unknown for now. There is only one router, right, in the HSRP group, and that router is the active router. So there is no standby till now. Priority is 100, the default priority, and then group name. This is the name of your HSRP group. HSRP fast Ethernet means interface type, then interface ID, and after that group number is nothing but the by default name. You can change this name if you want to change it. Now guys, on router number 2. On router number 2 also I am going to enable HSRP. And before that, let me do one thing, debug IP HSRP, debug HSRP note okay, we'll see the debugging command. What is that command? To enable HSRP here, what I will do, interface F0/0. On interface I am going to run command standby, then the group number is 10 and IP address 192.168.10.100. That's it. Now guys, so standby. State is listening. State is listening. Now state is speak means it is going to send the hello message, right? And router 1 is keep sending hello message after every 3 seconds, right? So now you can see this router is what? Speak to standby. But guys, router 2 should be active router because router 2 have higher IP address. But why router 1 is still active router? Because preemption is disabled, means election for the active router is disabled. After election of active router, these routers are not going to perform election for active router, and preemption for standby is enabled. That means when I will enable HSRP on router number 3, then router 3 will become standby, not router number 2 will be standby, because preemption for standby is enabled, preemption for active router is disabled by default. So go to router number 3, and on router number 3 I am saying interface F0/0 standby group number 10 IP 192.168.10.100. So standby, speak. Soon you will see this router will become what? Standby. Here see the log message. State move from speak to standby. Right? Now guys, so standby. See the configuration. HSRP group number 10 is enabled on fast Ethernet 0/0. State is standby. That means this router is the backup router of active. Right? Standby router. This is the virtual IP address. Right? The active virtual MAC address is this one, and the local virtual MAC address is also same. Timer due hello time preemption is disabled, and this is talking about the preemption for active router. And now guys, here you can see there is information of active router as well. The active router is 192.168.10.1. This is the physical IP address of R1, right? So the active router is 192.168.10.1. Priority is 100, and it will expire after this time. But it will be receiving one hello message after every 3 seconds, so this timer is going to be reset. And standby router is the local router. On router number 2, you will have information of active router as well as standby router. Like you will see the IP address of both router, active router and standby router. Priority is by default this one, and this is the group name. On router number 2, if you will run command, and here you can see the log message. State of this router move from standby to listen, and so standby. Guys, standby router is 192.168.10.3 and the active router is 192.168.10.2. See, the timer for standby router is 9.984 seconds. If this router number 2 is not going to receive any hello message from standby router for 10 seconds, then R2 is going to declare themselves as standby. Yes or no? And guys, which router is the active router? R1. If R3 will not receive any hello message for 10 seconds from router number 1, it will declare themselves as active router. So see, if this link will goes down, then what will happen? Router 3 will not receive any hello message of HSRP from router number 1. Automatically this router will become what? Active, and router 2 will become what? Standby. Right? Clear, guys?
Sir,
Yeah.
I have a question.
Yes, yes.
19 IP address, highest IP address is a active router or
Yeah, highest
lowest?
IP address is the active router.
So in this case, 10.1 is a highest or lower? 10.1
10.3 is the
R1 is
highest now, but the preemption is what? Disable.
100 disable.
If you will
But
enable the preemption, then router 3 will become active router.
but all priority are same 100. So why this is 10.3 is active? 10.1 is active.
Are you listening me? What I am saying, preemption is disable. If you will enable the preemption, then R3 will become active router because R3 have highest IP address, largest IP address.
Okay.
Preemption means what? If active router is present, then do not perform election for active router. Right? So we need to enable the preemption. So on router number 1, let me enable the preemption, guys. Interface F0/0. Simply stand by group number 10 and say preempt. Right? Let me copy the command and I'm going to paste this command on router number 2 also. Now router 2 have highest IP address than router number 1. So router 2 should become what? Active here. Do so. Stand by. This router is in listening state. How possible, guys? How it is possible? Stand by number 10 and preempt. So stand by. Still this router is standby router. Router 1 is active router. And on router number 1 also you can see there is information of standby router. Not only the IP address, their priority as well. So preemption is enabled or disabled? Enabled. On router number 2, so standby. Preemption is enabled. On router number 3, so standby. Preemption is now enabled. So on router number 2, let me do one thing. Interface F0/0 says shutdown. And now this port, this interface, new default gateway will come up. Right? Say no shutdown. The new gateway will come up, guys, in HSRP group number 10. And why debugging command is not working? Debug. Okay, I can say I think standby. Yes. Debug. Standby. Yeah. Now I am able to see all messages. This router is sending hello message as well as receiving hello message, and so standby. Still in listening state. So always keep in mind preemption will not work with default priority. Preemption will not work with default priority. So now you have to change the priority as well. And how you will change the priority? According to your requirement. You know this is the primary link, right? So here you are going to configure highest priority. Here I can configure priority, let's say what, 100 or 110. Here I can configure what, 105. Here I can leave for the default 100, right? Or guys, here I can configure priority 100, 2, 3. Here I can configure 102, and here I can configure what, 101. So which router will become active? R1. Which router will become standby? R2. Which router will be in listening state? R3. What will happen if router 1 will goes down? R2 will become active and router 3 will become standby. Again, what will happen when router 1 will come up? Router 1 will become active router. So how it will work? How it will work? See, if this link will goes down, this router and this router will not receive hello message from router number 1 with higher priority. So router 2 is going to become what? Active router. When again this link will come up, again it will receive hello message with higher priority. Again it will declare theirself as standby. Got it? This is how HSRP works. And guys, for the proof of preemption, what I can do, I can configure same priority on all the devices, right? Not default priority, because see, right now preemption is not working because of default priority. So on router number 1, I'm going to set priority 90. Let's say on all the devices I'm going to set priority 90. F0/0 say standby, group number 10, and then priority, let's say 90. And let me copy the command. On router number 2, interface F0/0. On router number 3, now which router should become active router? So standby. R3 is your active router and R2 is your standby router, right? And R1 is your in listening state, right? You can say listening router means the backup of standby. So when standby router will goes down, then this router will become what? Standby. This router is actually not ready for active, to become active. Router 2 is ready to become active because so standby, because state is standby. Done. By default preemption is disabled. You need to enable the preemption, but again if you will enable the preemption, make sure priority is not default. With default priority, preemption will not work. Now if I will talk about the hello message, let me show you what information will be there. Let's say router 1 is generating a hello message, right? So guys, in the hello message it will include priority, the most important thing. Then it will include their IP address 192.168.1.10.1, not virtual IP address, their own IP address. Through hello message only router 2 and router 3 are getting IP address of R1. Like on router number 2, you are able to see the IP address of active router, IP address of standby router. On router number 1, I am able to see which router is the active router, which router is the standby router. So standby, see, active router is 192.168.10.3 means router 3, and the standby router is 192.168.10.2 means router number 2, right? And after that, this is the information at application layer, actual information in hello message. Then guys, you will have UDP header. In the UDP header there will be source port number, the random port number, and destination port number. Destination port number will be 1985. The port UDP port number reserved for HSRP protocol. Then there will be IP header. In the IP header there will be source IP. Source IP will be what? 10.1. What will be the destination IP, guys? Multicast dot 2. Then layer 2 header, Ethernet header, right? In the Ethernet header, source MAC and destination MAC. Source MAC will be the MAC address of R1 and destination MAC will be what? Multicast MAC address. Note this MAC address, the virtual MAC address. Virtual MAC address is different thing, right? This is a MAC address for the virtual IP address, right? Device router is going to calculate one multicast MAC address on the basis of this multicast IP address. Always keep in mind, whenever router will encapsulate the frame, router need what? Destination MAC. So if destination IP address is unicast, then destination MAC will be unicast. If destination IP address is broadcast, then destination MAC will be also broadcast. If destination IP address is multicast, then destination MAC will be also multicast. Clear? This is nothing but your hello message in HSRP. Even you can capture the link. Do you guys want to see in the capturing? See here. Hello message. Which router is sending? 10.2 means router 2, standby router. Which router is sending this one? Router 3. Is there any hello message of router 1? This is, see the different message state. In the listening state, router cannot send hello message, right? It will send hello message. It will start sending hello message in speak state only, right? So R1 is not sending any hello message. It is only receiving the hello message, right? And if it will not receive hello message from standby router, then it will declare theirself as standby router. All clear? So guys, but there is issue. Issue is router 1 should be the active router, but who is the active router? Router number 3. So I have to correct it. For that I need to configure higher priority on router number 1. So I am going to configure 103 interface F0/0 standby group number 10 and the priority. Priority is, if you will not define the group number, here also I can run command like this, priority 103. Then what will happen, guys? It will set priority 103 for group number 0, right? So make sure here you have defined the group number, priority 103. Now soon router 1 is going to become what? Active router. See the log message. Because router 1 have already information about active router and standby router. What is the priority of active router? What is the priority of standby router? What is the IP address of active router? What is the IP address of standby router? And once I have configured higher priority here, router can check the information of active router and standby router. It can compare their priority and IP address. And now router 1 have realized that no, now I have higher priority. So let me send the hello message. So their state will move to first listening to speaking, and in speaking state it will send message. So R1 is the active router now. Guys, for now let me do one thing. Let me set the port. Again your R3 is the active router, and this time I am going to debug standby. and again let me say no set. Interface F0/0, say no set. See the state. This router is now active router. On all. Interface up. First state is initialization, initial, init. Init means HSRP enabled, right? Then quickly you can see state move from init to listen, right guys? And then somewhere you will find listen to speak also. Here it is learning the virtual MAC address, sorry, virtual IP address. No, this is the IP address of active router. Actually it have received the hello message. IP redundancy HSRP group, this update, okay, this one the state init to backup, and this one is the active router, no longer active for group number 10. So standby to passive, hold on down, then the active priority is this one. Here is the state, listen to active. What it's saying, fast Ethernet 0/0 neighbor 192.168.10.3 was active or standby, but the new active router is local router, this one, and then it is exchanging hello messages. Active and standby router will be keep exchanging hello message, and in the hello message see what informations are there guys. Priority plus virtual IP address, priority plus virtual IP address, and even in the capturing you can open any hello message of, let's say, let me open the hello message of active router. This is 10.2 router 2 standby router. See what informations are there. Opcode means type of message, then the state, then the hold on time, hello time, then priority, then group number, and the virtual IP address. Authentication, we'll discuss about the authentication later. Got it guys? Then at transport layer you can see source port number is random, source port number and destination port number, source port will be not random port number. HSRP uses same port number for source as well as destination. Source IP is the unicast IP address of the router, and the destination is multicast, and destination MAC also you can see the multicast. This is the corresponding MAC multicast MAC address of this multicast IP address. Actually there is one algorithm. Now we are not going to discuss about that algorithm. With the help of that algorithm, router can calculate MAC address of any multicast IP address. Clear? Then this was the operation when I had done the port. Hello message of R1 after running no set command. State, sometime you can see speak, then
Sorry, excuse me. What's the destination MAC address?
Multicast.
Yeah.
Multicast MAC address.
Thank you.
This one. This is not virtual MAC address for HSRP. Yes or no?
Yeah. Yeah,
It will
it's not
calculate
because
the MAC address, multicast MAC address on the basis of this multicast IP address.
yeah, which is the 000
Yeah,
four
that is the
zeros and then
virtual
after
MAC
that.
address. Yes.
Thank you. Thank you.
Let me close it. Now guys, here I have changed the priority. So standby. So that's why router 1 is the active router, and here you can verify the priority. Priority is 103 and the configure priority is also 103. So whenever this link will goes down, fast Ethernet 0/0 of router 1 will goes down. What router 1 will do? Router 1 will decrement priority by 10. And then what will be the priority here? 93. So you will see the priority is 93 and the configure priority is 103. So while troubleshooting, you can get to know that this router should be the active router, but maybe their link is down. On router number 2, so standby. So router 2 is not standby. Router 1 is the active and router 3 is the standby because of priority. By default priority over here is 100. On router number 3 is also 100. So it is standby. Election is happening on the basis of IP address. So let me configure higher priority here. On fast Ethernet 0/0, I'm saying standby, group number 10 and the priority 102. And guys, on router number 3, interface F0/0, standby, group number 10, priority 101. If you have more router, then you can configure priority there as well. Right, so according to the requirement, according to the primary link, secondary link and backup link, we can configure the priority. Now PC1 is able to ping the gateway, right? And guys, PC1 is pinging to which router? R1 or R2 or R3? R1, right? The active gateway is router number 1. Even PC can access internet, ping 8.8.8.8. See. Now on router number 1, I am going to down LAN interface. Config T, interface F0/0, say shutdown. Now tell me which router will become active router? R2.
3.
R2 bro. Here priority is
R2.
102.
Okay. Thank you.
R2 is the active router. And guys, do so standby. R3 is the standby router, right? If R2 will also goes down, shut down, then there is only active router. Only R3 is there. Only R3 one gateway is available. So here I am saying shut down, but still you can see PC1 ping is working. So two default gateway are down. Router 1 and router 2, still ping is working. Even I can set F1T, it will be keep pinging, right? Say no shutdown. See, again ping started working via router number 2. Router 2 is your active router. Again when router 1 will come up, interface F0/0, say no shutdown. See, your ping is working and now router 1 is the active router. Now router 1 is the active router. PC is still able to access internet. Any question guys in HSRP? Anyone have any question?
Yes, sir. For clarification, so this using the router one as the active router is purely based on the serial link bandwidth.
Yeah, on the basis of bandwidth. On the basis of bandwidth, on the basis of, the ISP, like, here we have only one ISP, but in real time, here you will have different ISP. Because if you are going to pay for 3 connection, then why you will pay to the same ISP? Because still there is no redundancy for ISP. If ISP will goes down, then connectivity will goes down. So let's suppose this ISP is more reliable than this ISP. ISP1, ISP2, ISP3. ISP1 is more reliable than ISP2. Then again router 1 should be your primary router, active router, until and unless ISP1 is up or this link is up.
Okay, thank you.
Right?
So with the virtual IP, if for instance there's a configuration, there's a DHCP configuration,
Okay.
how would that work for the router, for the pieces to
DHCP
use
is going
that?
to work same, exactly same. Let's say router 3 is the DHCP server, or router, any router, right? So DHCP server is what? Responsible to provide IP address. So in the
Right.
DHCP configuration, you are going to configure default gateway what? This virtual IP. Right? So whenever this PC will request for IP address, it will forward to router number 3. Right? Actually, it will broadcast it. All router will receive that discover message, but this router will drop it. This router will generate offer message. In the offer message, it will send the IP address and gateway IP address, default gateway IP address.
So in building your topology, you have to configure HSRP before you configure DHCP, or how? In which order?
No, now also I can configure the DHCP, and before configuring HSRP also I can configure the DHCP. The thing is, you have to make sure what virtual IP address you are going to configure. That should be the default gateway in DHCP configuration.
Okay,
Right?
got it. Thank you.
And in real time here you will have multiple switches as well. Like this. Right? Again things will work exactly same. Now I have multiple gateway, 3, 3, 3. Total 6, 9 gateway are there. So out of 9, 1 will be inactive, 1 will be in standby, and rest all 7 will be in listening state. Any other question?
Sir, one questions regarding for router 1 and ISP in between, if the link is down, so what is
Then
the solution
let
here?
me try. See, interface serial 2/0 and say shutdown. Now see the communication. Ping is not working. Destination host unreachable. So guys, the reason is router 1 HSRP protocol don't know anything about the WAN link, right? It is tracking only LAN link, this link. So still the active router is router number 1. So PC is forwarding traffic to switch, switch is forwarding traffic to router number 1, and router 1 is dropping the traffic. In this scenario, your failover will not work. Right? So what is the solution? Solution is you can configure now higher priority on router number 2. Manually you have to change the configuration, or you can tell to HSRP protocol on router number 1, please bro track this link. I can say track the line protocol of this port. If the line protocol of this port is down, line protocol down means if this interface is down or this interface is down, then decrement the priority by 10. Here I am saying no set. Again after some time ping will start working.
Sir, question?
Done. Ping is,
Question.
yeah.
So I thought track was inbuilt.
Track is inbuilt means you don't need to configure any external feature, but you have to enable it. By default it's a disable. Track feature is there in the HSRP protocol, but you have to enable it. Done. Now guys, PC is able to access internet. And see if line protocol will go, sorry, LAN interface will goes down like F0/0 shut down. What will happen? It will decrement priority by 10. So stand by. So you can see the priority over here is priority is still 103. Here priority should be now decremented by 10. This can be the issue of software only, right? It will decrement priority by 10, and once it will decrement priority by 10, router 2 will receive. By the way, here in this scenario, if this link will goes down, then it will not send any hello message to router number 2 or router number 3. So router 2 will declare their self as active router, right? And guys, if this link will goes down, again what will happen? Their line protocol of this port will goes down. That means router 1 cannot send any hello message, right? So the reason why here you are not able to see decrement in 10 is this router 1 cannot send any hello message from this port, right? When I will use the track, when this link will goes down, in that scenario you will see it is decrementing priority by 10. So for now I am going to up this port interface F0/0 say no cert, and let me use the track now. So to use track I'm going to say standby group number 10 and let me call track. Now track, which interface you want to track? Track serial, I think interface serial 2/0. I'm going to track this port serial 2/0 and then put question mark. What priority you want to decrement, right? So guys, I can decrement priority by 5. So I'm saying 5. That's it. So once this serial 2/0 will goes down, it will decrement in priority by 5. Then what priority will become over here? 98.
98.
Right? And if I will not define this number, then it will decrement by 10.
10.
Now see, ping is working, right? And now I am going to down WAN link interface serial 2/0 shut down. See, ping again started working, right? Only 2 packet loss is there. The reason is do so standby. See, priority is 93 and the configure priority is 103. So once this interface will goes down, it will decrement priority by 10 and then it will send hello message. So guys, in this hello message priority is 93. So on switch 2 and switch 3 will receive this hello message. These switches will get to know now R1 is not the active router. So R2 will become active, R3 will become standby. Got it? Again I am saying no set to serial 2/0, serial 2/0, no set. Again it will add in priority by 10. Do so standby. Priority is again now 103. Again in the next hello message priority is going to be 103. So switch router 2 and router 3 will get to know router 1 is the active router. What will happen if ISP link will goes down, like serial 2/0? This port will goes down. I'm talking about this port. Config T and interface serial 2/0 से shut down. Again packet loss. What is happening, guys? Router number 1, there is no any change. No any change. So with the help of inbuilt track feature, you can only track this link, right? Even on the real devices, if this port will goes down, what will happen? Line protocol of this port will goes down. But here in GNS3, so IP interface brief. Guys, on fast Ethernet 0/0 line protocol is what? It's showing up. So this is the reason why router 1 is not decremented in priority. So this is issue of software. On real devices, if this port will goes down, then also router is going to decrement in priority by 10. Done. So on the ISP router, again I have to run shutdown command, and this is the reason why you can see PC1 is able to ping again. How is ISP up? No, its line protocol is down, so standby. This router is in listening state. Okay, it have decremented priority, so IP interface brief. I think it was taking some time, so IP interface brief. Now still the line protocol is up. This is some error, right? The line protocol is, sorry, serial 2/0. This is serial 2/0. Line protocol is down. Okay. It's my mistake. Line protocol of serial 2/0 is down, right? So once line protocol will goes down, it will decrement in priority by 10. Done, guys. So if ISP router will goes down, or their link will goes down, their port or the link, right, it will decrement in priority, and shipping is again working via which router? Via router number 2. Via router number 2. So standby. How we can identify the router? Like which router is forwarding the traffic? By running this command, right? We can check the active router IP address. 10.2 means router 2. So router 2 is forwarding all traffic to internet. Got it? Clear, guys? On the ISP, if again this link will come up, their line protocol will come up, so IP interface brief exclude unassign. Line protocol of this port will come up. See, it's taking some time, but after some time you will see this line protocol will come up, and once this line protocol will come up, it will become active. See, this router is now active and the ping is working. Now if the LAN interface of R1 will goes down, interface F0/0 shut down. Now router 2 will be forwarding traffic. Router 2 will become active router. Now you can see router 2 is the active router. And guys, if the WAN link of router 2 will goes down, then what will happen? Interface serial 2/0 shutdown. Now ping will not work again. See, ping is not working. Why? The track is disabled on router number 2. So router 2 is not tracking the WAN link. Correct. So guys, on all the router I have to configure track. Still there is some issue. First of all, let me enable the track here. Standby number 10 track serial 2/0. Now you can see getting reply, right? Ping is working. In the same way on router number 3 also, interface F0/0, standby number 10 track serial 2/0. Now everything is working fine. Now guys, try to understand one another scenario. See, 8.8.8 is what? One service, one resource on the internet, right? So if that resource will goes down, let's say here is server 8.8.8. If this server will goes down, then what will happen? Connectivity will goes down. Like let's suppose here I have internet from another ISP. Here I have internet from this ISP, and here I have internet from another ISP. On all ISP 8.8.8.8 is there. 8.8.8 is there. Correct? So router 1 is my active router. Router 2 is the standby router. This router is in listening state. Fine. If this link will goes down, there will be failover. Failover will work fine. Router 2 will become the active router. Correct? If this link will goes down, then also failover will work. Right? Router 2 will become active router, and router 2 will start forwarding traffic. If ISP, this interface will goes down, then also failover will work. But what if this service will goes down? Will failover work then? No. Because router 1 is only tracking the line protocol of this port. So guys, to track the service, you have to use external tracking feature. This is what inbuilt track feature in the HSRP. So through inbuilt track feature, you can only track the line protocol of an interface. You can not track the service, but with the help of service, even we can track the server. Like I can tell router 1, bro, do one thing, keep checking reachability to 8.8.8. I can say, do one thing, after every 10 seconds send one ICMP packet to 8.8.8. And if you are getting reply, then fine. But if you are not getting reply, then also decrement in priority by 10. That is also possible. But you have to use then external tracking feature, that is IP SLA. SLA is what? Agreement. Service level agreement. Like guys, you know, the ISP is going to promise you like 24-hour uptime, right? Like your network is going to be up 24/7. So ISP is going to sign the agreement, right? agreement can be not 24 hour, it can be like 23 hours also, like for 23 hour, at least 23 hour network will be up. So now how we can track that agreement? With the help of SLA. With the help of SLA. SLA is used to track the ISP, to track one IP address, to track one service, right? So let's suppose this ISP is saying this service 8.8.8 will be available 24/7, right? So you can configure SLA to track the 8.8.8, and we can use that SLA, that agreement, for HSRP protocol. We can use that SLA for HSRP. The actual concept of IP SLA is, as I told you, for the service level agreement, right? But we can use it in HSRP. Done. Interface F0/0 standby number 10. We can change the timer, we can change the priority, we can enable and disable preemption, we can change the name, we can configure the virtual MAC. Now you can define the virtual MAC address. Then guys, see the one more difference between version 1 and version 2. Version 1 does not support IPv6. This is the main difference. Does not support IP version 6. So when we reduce IP version 6, then Cisco reduce HSRP version 2, right? To get redundancy in IPv6 network, it support IP version 6, right? After that the IP, then flow, then authentication. Track. After the track, what it's saying? Call to the object. So I can say, first of all, let me remove this track command, serial2/0, this track. And now I can say standby number 10 and then track. And this time I am not going to track the interface. I am going to call track object. Let's say track object number 10. And I am saying decrement in priority by 5 whenever this object will goes down, whenever the track will goes down. Now when track will goes down, do so track. Okay. When track will goes down, guys, when the track object will goes down. So now here I need to create one track object. So say track and then number, the object number 10, and then IP SLA, and after that it's the entry number, SLA number is 10, and then I am going to check reachability, and here that's it. Now one more command, IP SLA and the monitor. Now we need to define the IP address, IP SLA 10, and here I can say do one thing, send ICMP echo request message to 8.8.8.8, right? And from which source? Even you can define the source interface and source IP. Like I can say from source interface fast Ethernet 0/0. From the LAN interface, please keep pinging 8.8.8. And guys, like we can set the frequency. After 10 seconds you want to send the ICMP packet, or after 5 seconds, after 2 seconds, right? So you can configure those things. After running this command, what will happen? This router will start sending ICMP packet to 8.8.8. Debug IP ICMP. Is it sending any ICMP packet? No. The reason is I have created the SLA, but I have not scheduled the SLA. So I need to now schedule the SLA. So IP SLA schedule. SLA number 10. And when you want to schedule the SLA, for how long? So let's say for lifetime, forever. And when you want to start, so let's say start from now. So I can say start time, this start time now. So from now it will start sending the SLA. Even as I tell you, this is agreement. So we can, track a particular service like at 11 p.m. to 12 p.m. right? So we can schedule the SLA for that time. Once I will hit enter over here, let me check, is there any other option? No. Once I will hit enter, you will see this router will start sending one ICMP packet to 8.8.8. From which source? From fast Ethernet 0/0. And so track. Now track is, guys, up or down? Track is down. Now you need to troubleshoot it why track is down. So ping 8.8.8.8 and source fast Ethernet 0/0. Source source from router number 1, source invalid source interface, IP not enabled over here. Okay, so the line interface F0/0 is down, I think, right? Interface include or exclude unassigned. Yeah, this port is down, administratively down. So let me up this port, interface F0/0, say no set. Now let me ping. Yeah, now ping is working. So let me check the track now. So track is still down. So if track is down, then so standby. Priority is 98. If track is down, then priority is 98. It will decrement in priority by 5. Now question is why track is down. So track. Guys, in the track you are using what? IP SLA. And see, it is sending one ICMP echo request message to 8.8.8 from a particular source, from this source 192.168.10.1, right? And it is getting reply as well. So now track is up. Track is up. You can say reachability is up. So if track is up, then so standby. Priority is 103. And if priority is 103, then this router is the active router. So now, guys, we are tracking the service directly. Now we are directly tracking the service. Clear to everyone? If 8.8.8 will goes down, see, now on the ISP I'm going to down 8.8.8. do so IP interface brief 8.8.8 loop back 1, right? For now router 1 is your standby router, so standby, you can see this router is the active router because of priority. But if 8.8.8 will goes down, interface loop back 1 says shut down. Now what will happen? Track will goes down on router number 1. So I didn't configure the timer, right? So this is working on the default timer, right? It might take some time, but after some time you will see track is down. So track is still up. It is going to send one ICMP echo request message after some time, and this time it will not receive the reply. Once it will not receive the reply within the defined time, track is going to be down because IP SLA will goes down. If IP SLA will goes down, then my track will goes down, because in the track I have called to SLA. So you can see it have sent the ICMP echo request message, and this time it saying what? Host unreachable. So if host is unreachable, then your track is down. That's why you can see HSRP state is speak. Now standby. Right. So track. My track is down. And if track is down, then so standby. It will decrement in priority by 5. So priority is 98. Configure priority is still 103. So with the help of this output, you can find the issue, right? This router should be the active router, but their priority is 98. Configure priority is 103. That means the service is down, or the interface is down, or the line protocol is down. It is sending the ICMP echo request message. It will keep sending, right? Because I have scheduled the SLA. Now I am saying on all. This is all about HSRP protocol. Now guys, the next protocol is VRRP. To understand the VRRP, tell me one thing. Can I achieve load balancing here? Answer is no. Let's suppose here I have two VLAN. VLAN 10 and VLAN 20. VLAN 10 and VLAN 20. So guys, if I want to achieve load balancing between VLAN 10 and 20, then I have to create two groups. If I will create two groups, then active and standby routers are going to generate two messages after every 3 seconds. This is the issue with CPU. So within a group, can I achieve load balancing in HSRP? Answer is no. I have to create two groups, right? For one group, I can configure here priority. Let's say this is the priority for VLAN 10. And for VLAN 20, guys, here I am going to configure priority, let's say 50. Right? For VLAN 20, here I am going to configure priority, let's say 100. And here I am going to configure priority 40. So which router is the active router for VLAN 10? R1. Which router is the standby router for VLAN 10? R2. And this router is in listening state. Which router is the active router for VLAN 20? R2. Which router is the standby router? R1. And which router is in listening state? R2. So here, for this, you have to create different group. For VLAN 10, my group number is 10. For VLAN 20, my group number is 20. So that's why Cisco designed one more protocol that is called GLBP. Before talking about the GLBP, HSRP is in Cisco proprietary protocol. What? For other vendor devices. So that's why guys, we have what? VRRP. So VRRP is open standard protocol, and there is no any difference between HSRP and VRRP. VRRP stands for Virtual Router Redundancy Protocol. It is an open standard protocol. Hello time over here is 1 second. And the hold on time is 3 seconds. Right? The main difference between HSRP and VRRP is, it is an application layer protocol, layer 7 protocol, and VRRP is an layer 3 protocol, network layer protocol. So if it is a network layer protocol, then this protocol will have what? Protocol number. Protocol number. So guys, protocol number of VRRP is 112. The multicast address is 224.0.0.18. Okay. By default, again, preemption is there in VRRP, and by default preemption is enabled. Right? It support authentication. Yes, one more thing in HSRP, that is authentication. So guys, for authentication, let me show you how to configure the authentication. On router number 1, first I am going to up the service, say no set. In the same way, on all router you can track the service. So again you can see ping started working. Earlier ping was not working. Done. On router number 1, config T, interface F0/0, say standby, group number 10, and authentication. So we have plain text authentication and the MD5. Right? So here guys, I can configure the password. Let's say Cisco 123. So same password you need to configure on all rest devices, on router number 2 also, and router number 3 also. So standby. Is there any information about standby router? Standby router is, guys, unknown. If sometime, you know, while troubleshooting, it is very important. Sometime you will see the standby router is unknown. If standby router is unknown, it means what? It means this router is not receiving any hello message from standby router. That means there is no reachability. That means there is no reachability. Let's say on switching the switch, I can configure the ACL to stop communication between 10.1 to 10.3. In that scenario, there will be no reachability. So this time what is happening? The password. On router number 1, password is configured. On router number 3, password is not configured. So router 3 will send, router 2 will send their hello message without password, and router 1 will send their hello message with password. Both are not compatible with each other. So on router number 2 also I have to configure authentication. So standby, group number 10, and say authentication Cisco 123. Now router 2 will also send password in their hello message, and now you can see the output. So standby. Now standby router is 10.2, right? But guys, now router number 3. So standby. Router 3 don't know anything about the active router and the standby router. That's why it's saying I am the active router. What it's saying? I am the active router, because it is not receiving any hello message with higher priority or higher IP address. Right? So this is one interview question. Question is this: all routers are saying I am the active. HSRP state on all router is active. What can be the issue? There is no reachability. If router 2 is not going to receive any hello message from router 1 and router 3, definitely it will think I am only in the group. I am only in the network. So I will be active router. Same thing is happening on router number 1. If router 1 is not receiving any hello message, then it will think I am the only in group. Same thing for router number 3. Right? So interviewer can ask you these types of questions. If all routers are active, then how to troubleshoot it? So we will verify the reachability. Anyone have question? Any question, guys? Any question?
None from my side.
Good, Vikas. Bezat? Syed? Raghav? Tusti? Praveen? Anybody have any question? Murali, Hers? Pavitra? All clear? From why to how? Why, what and how? Is all clear? So tomorrow